So number 24 on the QR code review is asking us to answer some questions about a function where it gives us L of t is 10 e to the negative 0.236 t. And this is all about number of milligrams of medicine in a patient's bloodstream. So something very applicable if you're taking medications. So part A says, what's the initial amount of the drug administered? The initial amount is just your base amount right there. So that's just given to you right now. So that's just 10, and the units of this thing are milligrams because dosage are usually given to you in milligrams, and it says so in the problem. Part B says how many milligrams will be present after 1.5 hours. So really all we're looking for is L of 1.5. So you're gonna take 1.5 and evaluate your function. You're gonna need your calculator for that. So 10 e to the negative 0.236, and then let t be 1.5. So you have to get your calculator out to do this. So here's my calculator, and I'll show you exactly how you would plug this in. So we would go 10, and then second e, and then caret, and then we want a negative. Now the negative button is the button below the 3. It's not the subtraction sign. So you want to go negative point, what is it? 236, sorry. And then a parentheses, and that's going to be 1.5 because that's the time that we're looking for. End parentheses, okay, push enter, and you should see 7.018. Doesn't say to round anything, so I'll go to 3 decimal places just for accuracy. So this is going to be approximately 7.019 milligrams left in the bloodstream after an hour and a half. That's what that means. That's how we interpret that. Okay, then part C, it says how long is it going to take for half the dosage to be in the bloodstream, and then give your answer round to the nearest minutes. Okay, so half the dosage of 10 milligrams is 5 milligrams. So you're going to set up and say 5 is equal to 10 e to the negative 0.236, and then t is what we're looking for. So we want to solve for t. So I'm going to have to use natural logs in this case because this is going to be, since the thing I'm looking for, the variables in the exponent, the way to get that out of the exponent is to solve using logarithms. Now in this case, my base is e, so I know I'm going to have to use a natural log at some point. All right, anyways, let's divide both sides by 10. Boom, boom. So 1/2 is equal to e to the negative 0.236 times t. All right, so from here, I'm going to take the natural log of both sides. So the natural log of 1/2 is now equal to, now I know when I take the natural log of e, it's equal to 1, and I can use the power property to bring this down. So this is just going to be negative 0.236 times t. Now the only thing I have to do is solve for t by dividing both sides of the equation by negative 0.236, negative 0.236. Therefore, t is going to be approximately, now here's again, you have to plug your calculator because you can't solve for that. So go on, turn your calculator on, and we're going to do the natural log, which is this button down here. And we have 0.5, so 0.5 divided by, and then parentheses, looks like negative 0.236. Make sure I plug that in correctly. Yep, that looks right. Push enter, and it looks like 2.937. So this is 2.937, so that's like 2.94. Now this is hours, but it says to give your answer in hours and minutes rounded to the nearest minute. So it's 2 hours and then it's 94% of another hour. So you have to figure out what's 94% of another hour. So take your 0.94 and multiply it by 60, because that will give you 90% of an hour. So that's 56 minutes, 0.4. So I'm going to say 2 hours and 56 minutes. And that's what the question is asking for us. And that's how we got 2 hours and 56 minutes. All right, hope that makes some sense to you.